Hey everyone. Here is our first dive into MATLAB. Now, some of you may have already touched this a little bit, some of you may not. So this is starting at the very base level, as if I had just opened up my my MATLAB program. And that's what it would look like here. Now, I already saved it as something else here, but you can easily go to the home page and you just do a new. But what you want to do is a uh, new script like that. Okay, and then you can open up untitled. And then of course you should always save it immediately. Now I've got mine saved like this, but you should of course do a save as. So home, where'd it go? And what you want to do instead of a save is that what you do is you do a publish. So there's a save and then a save as, and then you should put your name in it. So Joe Smith, um, and then ES175 and um, homework one, something to that effect. Probably have some instruction there. So then you hit save on that, and oh goodness, look, we have to have underscores in between things. So hit underscore, underscore, and underscore. So it's a little old school like that. Okay, so now we've got this here. All right, so that's how you make sure that you set those things up right. Um, so you got home, new, might already start off with a new one, but make sure it's like you wonder where's the save as button. Well, here it is under publish. We're going to go back to publish in just a little bit, but we'll get to that later. So home. All right. So you're probably asking, oh, okay, what's the minimum I need to do to get this thing done? All right. Well, let's start just a one step before that, which is what's the point here? We're trying to just give you an introduction as to how to use it and a little bit of the syntax and so on. That's all. This is not this is not high level. This isn't super crazy. I know you're busy. So, what do you need to do? Well, I just need you to type through a few of the basic kinds of things. So first off, so I'm going to go through straight up what's going on with this assignment. Okay, download and install MATLAB. All right, hopefully you've already done that because you're already here. All right. Now the first bit here is that yes, we can get it through the college. I have yet to get that licensing, but the folks at MATLAB say it's okay. Just go do the free trial. I know we've paid for it, so I'm not too worried about the ethical aspects of it. Um, and so you can go through the I guess I think I already downloaded that, so let's get rid of that. And here you can go to the free trial, or I've got it right here that you can download it from my Google file. Okay, so when you do the install, make sure you uncheck all of these things. You're not going to use any of them except MATLAB. We're doing real basic stuff here. Okay, so what you should be doing is you should be doing the MathWorks tutorial first to get an idea of what's going on there and how to create and save a program. These are very basic setup things. So those things you should do first. Hopefully you've already done them before you hit this video, because next thing I'm going to do is I'm going to post this video like in part 2 here. All right, so hopefully you've done all those things so that I can just go quickly through the programming basic functions. Okay, so first step though, even before you hit here, we're going to set this thing up. If you use the percent sign, that means that you're doing some form of a comment. Double percent means that you've got like a major break in what you're doing from one section to the next. So you should start off like that. So start off with Jeffrey Burt, even though it says Joe Smith, um, ES 175, MATLAB assignment 1. Okay, So label it with your name and anybody else that's on your team. Okay. Always do this. Put your name in the file name and at the top of whatever file it is. I cannot tell you how annoying it is and frustrating it is when I get a file and it's just, I may have gotten an email from you, but I don't remember whose it is, or maybe someone didn't put their name in the file, if it's a team or something. Just do it. It's not that hard, and it's really helpful and reduces a lot of stress on everybody's side. Okay, so I'm going to comment out this. Just to remind you, this is a comment. Now, comments are really important because that tells first off, it's good for you to review what you did. Second off, it's good for you to tell me that you know what you're doing. And third off, if you're actually making this program for someone else to actually use, not just grade or whatever, um, they need to know what each step does. Sometimes these things get really complicated. I'm showing you some simple stuff, but it's really good practice to show it. This is part of design intent. If you're going to design a program, you should make it clear as to what each section does. So that being said, here's the next section. I'm going to start with another double. Oh, look, a line shows up. Isn't that special? Yep, that shows it's a new section. So the first thing we've got here are programming basic functions. Okay. And we are going to first define A and B. Now, from this point on, I am not going to comment, and that's for two reasons. Number one, I don't want you copying my commenting. I want you to review what you're doing. Number two, I want this video to go on for a shorter period of time. So obviously it takes me time to do this and talk about it. So I'm going to stop commenting from here on out, other than maybe just throw a couple of extra sections in there or something like that. So the first thing I'm going to do is define A and B. Okay, I'm gonna define A, and so that's this part right here. A is going to be 3.14159. Big surprise there, right? Okay, and B is going to be 2.718. Bet you don't know what that is. Okay, so here we go. I've got my A and my B. Did that. So next step, summation. Okay, so summation is very simple. I'm going to, now, there are a couple things. You see this highlighting thing and these red underlines. It's suggesting that I put semicolons after that, okay? And that is so when I'm defining the variables and it gives an output, that the output doesn't show these things. I'm just defining it. I don't need to output everything. But in fact, I actually do want you to output these things to start off with. And that's why this is showing up here. So if I just go over here to where to go? Where's the running part here? I think it's here, editor. There we go. If I hit run right off the bat, watch over here and watch what happens down here. Okay, what happens down here is that A and B show up as if, just similar to this. And I now have two new variables, A and B. I'm going to expand this out so you can see better. And it even shows their values and so on. And in fact, you say size 1 by 1. What do you mean? What's that? A and B are actually vectors now. They're 1 by 1 vectors, only one space for one in there. So it automatically thinks that variables are vectors. In fact, MatLab is not math laboratory, it's matrix laboratory. So immediately puts everything into matrices. So these are each in their own 1 by 1 matrix. Okay, so I'm going to move this back here, see if I can change this around a little bit. There we go. So now you can see what's going on over here. Now to clear out my command window, I use CLC and that clears everything else out. And then to clear out the workspace over there, I do clear all. Okay, so now I'm just going to throw this in. So now you can see what happens when I hit run. Okay, nothing comes up down here other than I ran Joe Smith, the name of this thing. But A and B got defined. That's what this did. This defined them. So if I just take this one out and I hit run again, it should print out what B is, but not what A is. Okay, so it ran Joe Smith. If I just want to run it, then I just type in the name of the file and it just automatically runs it. So 2.7180. All right. So let me go back to here. So when I'm teaching this stuff, I want it to be printing out and showing what's going on. Eventually, we will want to get rid of that kind of output. But so I'm going to go back to, and if I want to hit a command that I did before, I just hit the up button and can clear all. CLC, there we go. So now everything's all cleared out. Now you don't have to clear everything out like the clear all, but sometimes you're wondering what the heck's going on with that, and you realize that you got extra stuff over here. You might want to do a clear all. Okay, so next, going back over to the assignment, subtraction, big surprise. Oh, sorry, summation and subtraction. So if I want to sum A and B, by the way, I want everybody to use their own variables, not mine. So I'm going to instead call this Albert and Beatrice. Okay, and now I've got new, sum Albert Beatrice. Okay, and that equals Albert plus Beatrice. Okay, I'm trying to remember the shortcut on that, but that's okay. So very surprised. So what I'm doing here is I'm creating a new variable. I'm defining it by previous variables. If you try to do it the other way around, good luck with that. It'll yell at you saying that you didn't define these first. All right. So if I instead subtract, I can just copy this if I wanted to, paste, and I'm going to call it sub and make this minus. Now there's some shortcuts to some of these things, and I'm trying to remember what they all are, but it's not working. So sub Albert Beatrice. So if I run this now, you'll see that I now have two new variables, sub Albert Beatrice and sum Albert Beatrice. Of course, it's going to put them in alphabetical order. So A plus B is this, and A minus B is that. Okay. And they show up down here in the command window. All right, so next coming up, multiplication and division. Big surprises here. So, and you have to use the asterisk and okay. So you just use these kinds of operators. You're probably familiar with that. I hope that this is not too much rocket science for you. Okay, exponentiation. Now remember, for you, you've got to write in a comment for each one of these things, okay? Showing that you know what you're talking about. So exponent Albert to Beatrice equals, okay, big surprise here, Albert to the Beatrice power. Great. And then natural logarithms. So I'm going to call natural log of Albert equals, now notice how it's not ln. Not ln, it's log. So natural log is log. I think you have to do other things for other logs, but there's a lot of help online at MathWorks. But log Albert. Big surprise. You got to put in parentheses, and there's that. Okay, now if you want to evaluate any of these without actually running the program, especially since the program can be, once you get a complex program in there, it gets a little bit hairy. You can just copy this, put it in the command window, and excuse me, and you can just run it and see what happens. So this could just be a quick little calculator for you. So the natural log of 3.14159 is 1.1447. Just if you want to make sure that you got the command right or something like that. So you can do a quick check down here, but notice it also shows up over here. Okay, so we are now going to run into vectors right here, and I'm going to call it vector LB equals. Now you have to put it in those brackets, those square brackets. Albert, Beatrice, and there's that. Okay, so that is the first set of things here. And let's just hit run for fun, see what happens. Okay, all of these came in, and of course, because I did this before, there's no debugging necessary. Hopefully you won't have any problems, but if you do have to debug, like there's something comes back at you, well, you'll probably learn more than everybody else. Okay, so if you'll notice this vector came back and it shows the two values somewhat spaced apart, kind of like that, but should not be any big surprises as to what's going on over here. Okay, now matrices. Matrices are really important. And so we are going to start a new section here. Matrix definition. All right. Oops, Merrick's, good job. And operations. Okay, again, you are commenting, I am not. So I'm going to define, the assignment here is to define a column vector C and a different column vector D and a row vector F. So here we go. C equals, now to make it columns, see over here, we made this Albert Beatrice, and then we got these two in a row. Well, if you want to make them columns, you got to do something different. So we have to separate them by semicolons. So 1, 2, 3, and then no semicolon at the end. Okay, so let's see how that works. Notice how it's in a column now. All right, and it shows up over here. Okay, we're going to call that Charles. And watch what happens when I make Charles this. Notice how C stays up here. I already defined it. So until I do a clear all, that's going to stay up there. Okay, so if you ever wonder what's happening, sometimes you have to check and make sure that you got your stuff in order. All right, and David equals, oh, wait, let's do some negatives. -2, -5, 0.6. Ooh, getting crazy there. All right, so Charles and David are on there. And make sure you are commenting every step of the way. And then we're going to make a row vector. So Frank, sorry if I'm taking up all the names. You got to figure out your own. Equals, all right. Let's see, we've got 0. Now I can either put spaces between them, or I can make it even clearer by putting commas in between them. So 0 to -3. All right. So that's really not that hard here, folks, right there. 1, 2, 3. And then display the vectors. Now, because I didn't put any semicolons at the end, that's just going to happen. So that's fine. So maybe I should just leave that off there, but that's going to be just fine right there. Display the vectors. Okay, so now we're going to make operations on them. Okay. So it's sum CD equals, and we can do just like it was before, C plus, gonna have to be Charles in this case, Charles plus David, and then subtraction, right, subtraction, minus David, all right, and then multiplication. Now things are gonna get tricky. First off, notice how I'm doing just C and D, I'm not doing F. Okay. Oh, by the way, I think you can't use E because E is a special thing. Let's see. Oh, I guess not. There is something special about E. I think it's because of the value E 2.718 and so on, that you can't use it in some ways. I guess it's not just E there, but that's why I'm not using it. Okay, but also I'm using, I could call it Irvin or something like that. So that's not, doesn't that, just because it's not starting with E doesn't matter. Okay, so, but notice how Charles and David were both what excuse me, 1x3 column vectors. You can add those. It's like apples and apples. You can do it. But I can't add them and the row vector. They go opposite directions. So you can't add them together. So that's working on this. But you can multiply them. So that's what we're going to work on next. So multiply CD equals, I'm going to cheat-tastic here. Charles times David, and multiply FC equals Frank times Charles. Now, watch what happens with that. These are two different things. So I'm gonna hit run, see what happens here. Uh-oh, it didn't like that. Multiply CD Charles times David. I wonder why that is. It says incorrect dimensions for matrix multiplication. Okay, so the reason for that is that it says that they are different dimensions, and I'm surprised because it looks to me like they're the same dimension. So if you look up here, you can check that 3 times 1, 1 times 3, that kind of stuff. So it's a little confusing. Let me just do a and let's just try to run it again. You know what? I'm going to save. That's also a good idea. Sometimes things aren't saved. All right. Okay, it still didn't like that. Number of the columns in the first matrix matches number of rows in the second matrix. Oh, well, that's so when you do matrix multiplication, that you're going to run into that. You have to have a 3 times 1 times a 1 times 3, that kind of thing. So we're going to get rid of that and see if it solves our problem. Save it, run it. Oh, look. So our Frank times Charles did work because you can multiply those kinds of matrices. I'm not going to get into the math right here, but that's what we want to, that's one of the things I want to kind of bring up here is that you can't just throw that in there. You have to, of course, have the math rules go in there, but you can still multiply these matrices and it comes out pretty, fairly well. Okay, so now let us undo this. Can I undo it? There we go. And I'm going to do what's called a dot product. Dun, dun, dun. And then we're going to save it and then run it. Oh, look, that did work. That's because multiplying CD, I guess I'm going to go with you a little bit on the math here. Okay. Is, let's see if I can do this. All right. So if I've got Charles, which is a column vector of 1, 2, 3, and I'm trying to multiply it by David, which is -2, -5.6. The way an actual, matrix multiplication is I take the first, first column, first row, and multiply by this one. That's great. And I end up with -2. But then I try the first row, second column, there is none. Okay, fine. But then I go, then if that's the case, then I'm gonna have to go here to the next row and then multiply by the next column and row, next column of the first row. And there is no next column of first row. So then it brings in an error. But if I do a dot product, what you end up with is 1 times -2 is -2, 2 times -5 is -10, 3 times 0.6 is 1.8, and that's what we end up over here. That's why you have to have a dot product or a dot asterisk. But that's why we can do the multiplication with Frank, because I've got 1, 2, 3, and 0 to -3, so that it says, okay, first column, first row here times the first column, first row over here is 0. And then I take the second column. Okay, I don't have any more columns, so I've got to go second row, first column, and then I multiply it by the flip, the first row, second column over here. 2 times 2 is 4. And then I go with the next row and the next column. So as I'm going from my first vector, I go down the rows, and as I go to my second vector, I go down the columns. So 3 times -3 is going to be -9. And then I add them all up, and I end up with -5. And that's what you get there. Okay, so if one can't be done, if it's not following those rules, it'll give you an error. All right, so make sure that we do that. So multiplication C times F, you're gonna have to use, that's what I have here, is notice I've got C times F and F times C. I wasn't obeying the rules. I used I used C and D instead of C and F. So there's that. Okay, so let me clear out all the drawings and get back to where we were. So I'm going to multiply C times, C plus D, C times F and F times C. Oh, that's always fun. Charles times David. Frank. And Frank times Charles. All right, save it one more time and run it. Oh, so now you can see that running the this is going to do exactly what we want it to do. Charles times Frank is going to be 1, 2, 3 times 0 to -3. So what it does is it takes this one times this one and goes 0, and then this one times this one and goes 2, and then this one times this one is -3. Then we skip to the next row. 2 times 0 is 0, 2 times 2 is 4, 2 times -3 is -6, 3 times 0 is 0, 3 times 2 is 6, 3 times -3 is -9, and we end up with a whole new 3 by 3 matrix. If you're multiplying the column vector, the 1 by 3 column vector with the 3 by 1 row vector. But if we switch them, we end up with just a single 1 by 1 matrix like this, as I showed you before. Okay, so that worked out. And moving on a lot faster, hopefully here. All right, so we got the multiplications, and now you get the idea of basic vector operations. Now, I should call this mate vector. Vectors, as far as I remember, are just single dimensional, whereas matrices have at least 2 dimensions. Okay, so we've got matrix operations. All right, so now I want to create 2 different 4 by 4 matrices, M and N. So that equals block, and we're going to go with, say, relatively easy numbers, 8, 2, 0, 1. Then I put a semicolon in. So now I'm going to get to the next row. And we've got -2, 6, 2, -1. Okay, oops. I put that one a little too soon. Okay. And then all right, so now I've got all 16 elements in here. Okay, and then going to do the same thing with Nancy. Do I have any special thing that I'm doing here? No, but I'm trying to keep the numbers low because it's easier to check by hand calculations. But also, you don't want to put too many zeros because bad things can happen sometimes. And you also don't want to put everything positive because other bad things can happen sometimes. So. Okay, so it should be good enough. Let's see how that goes. Okay, so I got Matt and Nancy all set up. There are no errors whatsoever that I see, and that's probably going to take you the most amount of time, just deciding on which one of those. All right, now, we are going to do something fun with this. We are going to, it might help just to run this right now. And then you can see Matt and Nancy right here, and you can see which is which. So what we're going to do is that we are going to, using address techniques, multiply the fourth element of the first row of M with the second element of the second row. That's your job. I'm going to do something a little bit different. I am going to multiply, I'm going to do M23 equals, oh, sorry, M23 times N14 equals, and I'm going to find the second row. I hope I'm not mixing this up, but the second row of M and the third element thereof. Now that's the second row of M and the third element, that's 2, and I'm going to multiply it by Nancy, first row, fourth element. Okay, so that means this should be second row, third over. Okay, so that's 2. Nancy's first element, first row, fourth element, 1. So I'm assuming, if I've got that right, that it should come out to be just 2. If I'm wrong, then it's the second column, third row, which would be 3, and Nancy's first column, last row, which would be -1, so it would be -3. So let's see which it is. And let's run it. And it did not like that. Oh, that's because I used M and not Matt. Watch out for that. Okay. Save it, run it. Okay, so I was right the first time around. Okay, so M23 times N14. So I just took the second element, your second row, third element of Matt, and multiplied by the first element, sorry, first row, fourth element of Nancy, and 2 times 1 is 2. Okay, so like I said, that was defining those things was probably harder. And let's so then I've got I've got 2 of those. Multiply the last element of the first row, and then verify by hand calculation. Not too hard, folks. Multiply M and N as matrices. Do not use the dot function. Okay, so that means since they are both 4 by 4, they've got the same dimensions. We should easily be able to multiply them. So let's say mult M by N, oops, equals M star N. All right, so there's that. And then do it again, but use the dot function. Dot N equals M dot star N. All right, so that's so now the difference here is the same as what we had before. You're going to have M, and you're going to do first row, the 1 of the 1 multiplied by that 1 of this other, but then it's going to be 2 1 times 1 2, 2 1, sorry, 3 1 times 1 3, and so on, and it goes down the line. More of what I was showing you before. So let's run that and see the difference, because we're going to get 2 very different answers for that. Did I do that again? I did it again. All right, let's try that again. Okay, well, that was fast. All right, so notice how we got very different results, 2 very different matrices, very different values because of the different meanings between those two. So I expect you to put in your comments the differences between those. So that's where this question comes in. Okay, now that's the hard part probably. Well, all of that is, if you will, the hard part. So displaying operations. So let's do that one. Okay, display the vector value A, vector F, and M matrix you created by multiplying M and N using following techniques. Okay, so A, F, M, and let's just get to, there we go. So we got three things. So I can show you A. So if I just type here A, right, it just shows you, I guess it's not going to in this case. Oh, that's because I don't have one labeled. Okay, Albert. There you go. If I just type Albert, there it is. So if I type in Albert, guess what's going to happen? Boom. It's going to show you Albert. That's all you have to do for part A here. Okay, so there's Albert, there's Frank, and then there's mult m dot n. Okay, that's it. That's as tough as B as A gets. Okay, now B is using an fprint function. Now, I have an example of that somewhere here. Oh, thought I had a good example of that. Maybe it's in the next one. Oh, okay. So, but this is a little bit more user friendly. It doesn't just say boom. So you've got here f print f, and then you open up parentheses, and then you can do a whole bunch of things. But it's kind of clunky. I'll give you that. It's a little bit weird. But if you start with quote, you can put whatever you want to in the quote. The cool number is, and then if you put in this percent thing, this percent D, that D, it doesn't have to be D. It could be a variety of a few other things. You have to look those things up, but D is fairly common. And what happens is that after you do this, you put in some variables. And then so if I put a period after that, then it knows to put the period there. And then I have to put a comma, and then Albert. Then I have to close parentheses. So, oops, I should have put that in the, but if I just do that there it is. The cool number is this, and it gives it to you in a very specific format defined by this D here. There's all sorts of ways of changing the format. And if you don't want to put the E on there, decimal places and all that other, those are all available to you. If you want to play around with them, fine. But they're clunky and a pain in the butt. So if you've got better things to do, you might want to do them. All right. So if I take this fprint up cool number is this, I'm going to copy that. I'm going to put this in here. Remember, each step of the way, make a comment. Okay, fprint that is that. And then let's see what happens if I can do that with Nancy, because Nancy is different. It's a 4x4. Ooh, that doesn't look very good, does it? Okay, look at this. It keeps doing the same thing for every single one of Nancy's elements. Okay, so you might want to try to do something different, but that's where I give you this link here. If you click on here, it gives you some good tips on how to use fprintf. Okay. And then you can also use display. Let's try to display Nancy. Oh, that's much nicer, isn't it? Yeah. So there are reasons to use one or reasons to use the other. So those are the things that you might want to do. Okay, fprintf that. And okay, I did that. And then there's display. But I want you to do that for each one of these things. See how they show up differently. Okay. All right. Now, that's most of the programming. So finishing. All right. So I've already told you to use the double things to insert sections. Put your name at the top for the first section, just like I did here. Comment each section and step. Carefully describing what you're doing. Commenting is required and essential. See this essential, below. So here we go. See, isn't that absolutely magical? And then make sure your names are on the saved file name up here. Joe Smith and Jenny Johnson. I don't care. But okay, when you're satisfied with your work, this is important. Okay, one of the last steps. Now, this might not be available if you're doing the online version. So this is why I always tell you guys to download the stuff and do it locally. Is that we want you to publish it. Okay, right here, publish, and then go over here to publish, and then edit publishing options. Now, the default is going to be in HTML. No. PDF. Okay, hopefully make sure you see that. That's important. All right, don't be skipping by this part. Don't be putting me on 2x speed. I got you. We got stuff. Okay. All right. So if you put me on 2x speed, I'll just slow down. Yeah. So there's PDF, and that should be pretty much it. Make sure that you've got the right name in here and so on. Then just click on publish. But that's the key thing, is that we want to have an output file of PDF, publish, and it shows up somewhere. I don't know where, but at least I can figure that out. Oh, there it is. That's what I thought it would come up as. Hey, look at that. And this is how it looks like. And then it automatically, does all of the it kind of runs it automatically and gives you all that printout. Okay. So now look at all the variables we've created in this session here. Okay, well, that's probably enough for now, and you should be able to follow this pretty easily, and then get your assignments into me within, it's not as easy to make mistakes here as it is, say, in SolidWorks and get all bottled up. So hopefully that's going to work out for you. All right, take care, and hope to see all of you soon. Bye-bye.